Hey, what's up everyone? Today we're going to be doing a bit of practice balancing chemical equations, and I'm going to give you the number one tip for balancing chemical equations. You ready? The number one tip is that you should balance elements that occur only once on each side of a chemical equation first. So what do I mean? Let's look at this reaction here. You have carbon dioxide reacting with water to produce glucose and oxygen. Now, what elements occur once on each side of the chemical equation? Well, carbon here has one source. It's the carbon dioxide. There's no carbon anywhere else on this side of the reaction. And on this side of the reaction, carbon occurs only once. It's in the glucose. Also, hydrogen here occurs once in the left-hand side is from the water, and it occurs once within the glucose molecule. Now, oxygen would not be a part of this. Oxygen occurs twice on the left-hand side and twice on the right-hand side. So that means we should do oxygen last. Now, we have two options. We could start with the carbon or we could start with the hydrogen. But the general rule is that if you have hydrogen or oxygen, you should probably leave them for last. So let's start with the carbons. We have 6 carbons on the right-hand side. We have only 1 on the left-hand side. So let's add a 6 on the carbon dioxide to balance the carbon. Now we can deal with the hydrogen. Hydrogen here, there's 2 hydrogens, but on the product side, there's 12 of them. So let's add a 6 here. Now if you notice, this throws the whole oxygen count out of balance. We have 12 plus 6, 18 oxygens on the left-hand side, but on the right-hand side, we have 6 and then 2, so 8 oxygens. Now, we can't really manipulate this because our coefficients here are basically based on the fact that there's only one glucose molecule. But in order to balance out the oxygens, what we can change is the coefficient on this diatomic oxygen. We need a total of 18 oxygen atoms, and we already have 6. So if each diatomic oxygen gives 2 oxygen atoms, then we're going to need 6 of them to have 18 oxygens. So let's do a really quick check. On the left-hand side, we have 6 carbons. On the right-hand side, we have 6 carbons. Left-hand side, we have 12 hydrogens. On the right-hand side, we have 12 hydrogens. On the left-hand side, we have 18 oxygens. And on the right-hand side, we also have 18 oxygens. So this equation is balanced. You have 6 molecules of carbon dioxide reacting with 6 water molecules to produce 1 molecule of glucose and 6 molecules of oxygen. Now the rest of the problems here are basically using this idea in different ways, so let's do that. Let's look at silicon tetrachloride reacting with water to produce, I don't actually know what this is called, and then hydrochloric acid. So which elements occur once on each side of the chemical equation? Well, first of all, we have silicon. Silicon is, the only source is silicon tetrachloride. And then the silicon here comes from this molecule. So silicon is one of them. The other one is going to be chlorine. We have 4 chlorines and 1 chlorine here. It's the only source of chlorine on each side of the chemical equation. And we also have oxygen. There's 1 oxygen in the entire left-hand side. And on the right-hand side, the only oxygen is coming from this molecule. So we have 3 candidates. We have oxygen, we have chlorine, and silicon. We should leave oxygens and hydrogens for last, so let's not do oxygen. And for silicon, the silicons are already currently balanced, so you really shouldn't start with silicon. Let's start with the chlorine. There is 4 chlorines on the left-hand side and only 1 on the right-hand side. So we can balance that by adding a 4 on the hydrochloric acid here. Now, what this does is that it throws the hydrogen count out of balance. We have 4 hydrogens plus 4, 8 hydrogens on the right-hand side and only 2 on the left-hand side. And we can balance that by adding a 4 on the water here. And if you look, it's already balanced. Let's look at the silicon count. There's 1 silicon on the left-hand side, 1 on the right-hand side, 4 chlorines on the left-hand side, 4 on the right, 8 hydrogens on the left-hand side, 8 on the right, and 4 oxygens on the left, 4 on the right. So this is balanced. You can see that you basically start with an element and then that might throw things out of balance, and you have to deal with those as you go. Let's look at another problem, and I promise you this one's a little bit different. We have aluminum reacting with hydrochloric acid to produce aluminum chloride, I think it's called, and then diatomic hydrogen. Now, what are the elements that occur only once on each side of the chemical equation? Well, technically it's all of them. Aluminum only has one source on each side, hydrogen only has one source on each side, and chlorine only has one source on each side. We shouldn't start with the hydrogens because remember, hydrogens and oxygens should be left for last. The aluminums are already kind of balanced, so let's start with the chlorine. We have 3 chlorines on the right hand side and only 1 on the left hand side. So let's add a 3 here, and what that does is that it throws the hydrogen count out of balance. We have 3 hydrogens on this left hand side and only 2 on the right hand side. Since the only source of hydrogen is this diatomic hydrogen here, how are you going to get 3 hydrogens when you can only have factors or multiples of 2 hydrogens? Well, you could do a fraction. You could do 3/2 hydrogen that produces 3 hydrogen atoms, and that does balance the entire equation. But the thing is, you don't really want a fraction as a coefficient when you're balancing a chemical equation. Sometimes you might see it, but most of the time it's going to be a whole number. The way you can make all this whole numbers is by multiplying the entire equation by 2. So instead of having 1 aluminum, we could have 2 aluminum. Instead of having 3 hydrochloric acids, we could have 6 hydrochloric acids. And then instead of having 1 aluminum chloride, you could have 2 aluminum chloride. And then instead of having 3/2 hydrogen, you could have just 3 hydrogens. And that balances out the equation. I'm going to stop counting the atoms because I know this is right. But you should, in general, count out your atoms, at least in your head, to make sure that you balance properly. But trust me, this is right. Let's go to the next one. This is essentially the same idea, except now we're going to apply it to polyatomic ions. Whenever you have polyatomic ions on both sides of the chemical equation, you should kind of treat the polyatomic ion as kind of like an atom. So you have 3 sulfate ions on the left-hand side and only 1 on the right-hand side. So let's add a 3 here to balance out the sulfate ions. And what that does is that it throws the potassium count out of balance. We have 6 potassiums on the right and only 1 on the left. So now let's add 6, a coefficient of 6 on the potassium hydroxide to balance out the potassium. And what this does is that it throws the hydroxide count out of balance. We have 6 hydroxides on the left and only 3 on the right. So let's add a 2 here to balance that out. And if you notice, that automatically balances out the irons. We have 2 iron on the right, 2 on the left. And this is correct. This is all balanced. We have 2 irons on both sides, 3 sulfate ions on both sides, 6 potassium atoms on both sides, and 6 hydroxides on both sides. So this is balanced. But sometimes you're going to have a polyatomic ion and it's just going to break up. And here we have H2SO4 and HI to produce H2S, I2, and water. How do you balance this? Well, exactly the same as we've been doing. So which elements occur only once on each side? We have the sulfur here, and we also have the iodine. Now, the sulfurs are already kind of balanced, so let's start with the iodine. Let me erase this. Let me add a 2 here to balance out the iodines. And now we got to look for what do we tackle next? Well, let's tackle the oxygen. There's 4 oxygens on the left-hand side and only 1 on the right-hand side. So let's add a 4 here, and that balances out the oxygens. What this throws out of balance, though, is the hydrogens. We have 8 plus 2 hydrogens, 10 hydrogens on the right-hand side, and only currently 4 on the left-hand side. Now, you can't really touch this one because this has sulfur and oxygen, and we need to keep those intact. So how do you get more hydrogens without touching this? Well, you're going to have to edit the number here. Sometimes you're going to put down a number and you're going to have to edit it. We have 10, remember we have 10 hydrogens on the right-hand side and only 4 on this left-hand side. If you can't touch this sulfuric acid, you're going to have to touch this. And the way you balance out the hydrogen count is by adding a 8 here. Whoops, let me let me rewrite that. We have 8 here, and that what that does is that it we have 8 hydrogens here too, so that's 10 hydrogens, and this also has 10 hydrogens. But now you've thrown your iodine count off balance. So it's kind of like a back and forth game. You have 8 iodines here and only 2 here. But thankfully this is diatomic iodine, so you can just add a 4 here, and that kind of just balances out everything. And so that is your final balanced equation. It's kind of, sometimes you're just gonna have to go back and forth, sometimes it's really easy, but you should always remember that you should start with your elements that occur only once on each side of the chemical equation. That'll help you narrow down your steps, and it'll seem less like guess and check and more like a chasing game until you finally get your balanced equation. I hope this video was helpful. I hope you're able to learn something. Thank you for watching, and I'll see you later.